Hi guys, I'm back again, and now I just want to make sure that we get the notes for this lesson, okay? So in the textbook, at least right here, they're talking about making sure that we understand when we're given, oops, sorry about that, when we're given the equation, how we go about um, finding, using the slope and the intercepts to graph the equation. If you noticed the last time when I was doing the graphing, I really only cared about plotting those two intercepts and then connecting them. But this time I'm given an equation in slope-intercept form. So I want to plot that y-intercept. Notice that's the positive 1 right there. And then use that slope of down 2/10 and over 1 every time to get my the rest of my equation plotted. Now, I don't have to do it that way, but since it's already in slope-intercept form, that's probably what I would do. When you go to find the x-intercept, remember x-intercept means that the y value is 0. So I just replace y with 0 right here. They did it right here and they showed it up nice and highlighted in red here, so it's a little easier. So that when you solve that equation, you're really trying to solve for x and you get that the x-intercept is 5. So that's good because it matches the graph. Okay, and so what that means, make sure that you understand when they're saying and interpret the intercepts. Remember, you're going back to the context of the story. So if the x-intercept is 5, that was hours. That means the battery lasts 5 hours because once the number of hours has gone by, we're down to 0 on the y-axis, which means that's the percentage of power that's left. When you find the value of the y-intercept, it says find the value of y. Oh, this isn't even an intercept. It just says find the value of x when y is 75 hundredths. So this is 75%, right? So they want to know how long is it going to take until the battery has 75% power. So if I put in 0.75 for the power, remember that's y, I want to know how long it takes to get to 75%. And it turns out it's going to take an hour and a quarter, so an hour and 15 minutes. Remember, 1.25 hours, an hour and 15 minutes, until I have 75% of that remaining. Okay, so this is if you're given the equation, how to A, graph the equation and interpret the x and y intercepts, and then answer the third part of that question was making sure that you can substitute in for one of the variables. The second example is what happens if they give you the graph and they give you some of the information in that graph, but then you have to come up with the equation. That's a little harder. So in the first thing they ask you to do, they tell you, here's the graph. The first thing, find the slope and the y-intercept. Well, that's not too terrible. I've got the y-intercept right here. It's 0, 32. That means that's the plus 32 part of my equation, right? Down here, they show it right here. The slope is rise over run, or I can do change in y, 86 minus 32, that's going to be 54, over the change in x, which is 30. So here's where they got that. 54 over 30 is 9/5. You don't have to change that to a decimal. You can leave it as a fraction. That's perfectly fine. In fact, probably preferable because when you're graphing something later on, it's going to make it a little easier to do that. So the second, now that I've got the slope and I have the y-intercept, I can put that straight into slope-intercept form. Sometimes they're going to ask you for a different format of the equation. Don't forget, I could multiply everything here by 5, get rid of that fraction. I'd get 5y equals 9x plus 160. And then I can change that into standard form if I wanted to. Then it said in part C, find let's see, in degrees Celsius, the mean temperature of Earth is 15 degrees. To find the mean temperature in degrees Fahrenheit, find the value of y when x is 15. So they're actually already even telling you. Remember, x is representing the degrees Celsius in Earth, on Earth. So if I put in x as 15, then I can find, the mean temperature of the Earth is 15. Find the value of y. All right, so actually I missed it up here. Relates temperature in Fahrenheit to Celsius. Oh yeah, duh. 9/5 plus x plus 32. I should have remembered that. Anyway, okay, so when I put that number in there, I get 59 degrees. That means that it's 59 degrees Fahrenheit if it's 15 degrees Celsius. Those are just equivalents right there. So it's definitely worth giving it a try. What I'd like you to do is the online assignment and the quiz in the book, the 2.7 quiz. If you think you're going to need some more practice on this, you can certainly go down here through some of the other problems. You don't have to, you can do the ones online, but then you can come back and see which other ones you might not have done, if there are any. And you can also just email me. I'll be available, so you can shoot me an email. This is the quiz in the text 2.5, 2.7, and the quiz is coming up. So if there's anything on here, especially things like that we talked about on Tuesday, you guys can definitely get in touch with me. I know I'm going to miss you I missed you this morning for extra help. So you can also come see me tomorrow at WIN or at SSR if you're having trouble on any of those things. Okay, I'll talk to you soon. Good luck.